Hello, I'm Alistair Edwards, and I'm going to give a little talk here about artificial intelligence and specifically addressing the question, what does ChatGPT understand? So, what does ChatGPT understand? Nothing. So that's the end of my talk. I'll be happy to take any questions. No, I'm just joking, of course. That is the conclusion I'm going to reach. But I need to give some background as to why I'm suggesting that. So I'm going to look at artificial intelligence, a little bit about its history, how it developed, leading up to things like ChatGPT, and question understanding and AI. So first, though, a little bit of background. I am Dr. Alistair Edwards. I am an honorary fellow of the University of York, which basically means I retired as a lecturer several years ago. But one of the things that I do in my retirement is to give talks to schools, specifically through the organization Speakers for Schools, who do what it says on the tin. They provide speakers for schools. Now, I've written this talk on artificial intelligence that I could give to schools. As yet, nobody's asked me to do it. But several of my friends have asked me about it, wanting to know a little bit more about artificial intelligence. So I thought it was worth making a video to go through it. One more introduction I want to mention is this is our dog, Duke. I'm recording this in a study in our home, and Duke is downstairs. And if at any time he gets excited by people walking past the house or whatever, he may start barking. In which case, please don't be distracted. Okay, so let's dive in the question, what is artificial intelligence or AI? Now, I've heard some definitions recently from quite prominent people, which I don't agree with. My definition is that AI is getting a machine to do something that previously could only be done by a person. And if you think about it, that's a moving target, because you get an AI to do something that was previously only done by a person, and then it just becomes one of those things that computers do. And you have to move on to, well, what's the next thing that previously was only done by people? Now, the history of this sort of thing goes back further than you might think. In 1785, Edmund Cartwright invented the power loom, and this was specifically a loom that would do work that previously only people could do. Of course, it didn't call it artificial intelligence then, but the response to it was something that we would probably find quite familiar now, that they were taking away jobs from people. And the counter response was probably much the same. Well, those people can perhaps go on and do something different. But it's the same problem. Now, of course, that wasn't called artificial intelligence at the time, but you might think about it that in some ways there was intelligence built in to the power loom. The loom was doing things automatically that previously a person would have to decide about when and how to do them. So the term artificial intelligence was actually coined in the 1950s. I think it was 1956. There was a workshop at Dartmouth College in the States where the term was first coined. So we go back to the 1950s for the start of this history. And I want to look at something called a compiler. So a compiler is a particular piece of computer software. Now, as you know, computers operate on patterns of zeros and ones, on binary information. But if you're writing a program, you write it in what we call a high-level language, a language which makes sense to a person. So if you've ever written any programs, you'll know what they look like. Here is an example of a very small program in the language C. And you'll see it consists of English-looking words like main and mathematical-looking symbols like brackets and curly brackets. So how do we get that into a form that you can actually use on the computer? Well, if we go back to the 1950s, the program would look more like this. Again, a mixture of English-looking words like load and add and numbers, mathematics. And that would have to be translated into binary patterns like this. How would that happen? Well, the programmer, who would have written the program on paper and would load 100 and so on, and they would then have to look up in a table. So you'd look up the load instruction in the table and see that the corresponding binary code for that is 01000. So that would be the load instruction. 100 in decimal is 1100100 in binary. Add, look it up in the table, is 01011, and so on. So I'd have to do this translation manually from the higher level description into the low level binary representation. And here is a console from a 1950s computer, the Manchester Mark I. And you'll see there is there are rows of switches on the console. And I suspect that that was the way that the program would be entered. You would put switches up and for 0, down for 1, set up the appropriate pattern on those switches, press a button, and the corresponding pattern would be punched onto the paper tape that you can see on the left there, and that would eventually be fed into the computer and it would run as a program. So that was the situation in the 1950s. But then people had the idea, well, hang on, this looking stuff up in a table, translating from one form to another is very mechanical. It's the sort of thing we could get a computer to do. And so they developed the idea of compilers. And this became possible as the computers became more powerful, and particularly as they had more memory. So you had enough memory that you could have two programs, the program you were writing and the compiler to do the conversion in memory. So this was now doing something previously only done by people. Was it AI? Well, some people at the time did suggest that this was a form of AI. But of course, it soon became just the thing that computers can do. Compilers don't seem to be very particularly intelligent. They're just doing a very mechanical translation from one form to another, and you can generate compilers quite easily. So it fits in with my definition, but soon became considered nothing particularly intelligent. Now, something we'll notice as I skip through this history of AI that has experienced highs and lows. In the highs, a lot is promised and possibly over-promised, perhaps hyped. And the lows, where what seemed to be quite exciting previously is now just become one of the things that computers can do. And perhaps not all that was promised. So I'm going to have a quick run through an AI timeline. So again, we're starting in the 1950s. The concept of artificial intelligence, AI, is born. And largely responsible is this chap, Alan Turing. Now, if you don't recognize him in this picture, you might have seen him in this picture if you are the kind of person who still uses money and you're lucky enough to have as much as £50. Well, his portrait appears on the back of the £50 note. And you'll see there's a little quote from him there from the 1950s. And if you look this up, this is from an interview in the Times newspaper. And the whole thing, he says, this is only a foretaste of what is to come, and only the shadow of what is going to be. We have to have some experience with the machine before we really know its capabilities. It may take years before we settle down to the new possibilities, but I do not see why it should not enter any one of the fields normally covered by the human intellect and eventually compete on equal terms. So back then, he was already suggesting that computers could take over things that humans had done, compete on equal terms with the human intellect. So AI was born, and Turing had a lot to do with this, but he also, this was just one of his contributions. He practically invented the computer. Now, you're probably aware that he worked at Bletchley Park and Manchester University, developing actual physical computers. But before even that, he had invented a concept of a computing machine. This is something that became known as the Turing machine. And this was a thought experiment. A very, very simple machine, but actually it's equivalent to any computer that has ever existed. There's nothing that the most powerful computer available today can do that couldn't, in principle, be done by a Turing machine, and vice versa. And particularly important, if there's something you could prove it could not be done by a Turing machine, as he did, then it could not be done even by the most powerful computer. But he was also, while he was doing all this, he was also thinking about artificial intelligence. So you'll see he published this paper in as early as 1950 with the title Computing Machinery and Intelligence. And you'll see the first section of the paper is entitled The Imitation Game. And he says, I propose to consider the question, can machines think? Now, he kind of skirts around that in a little bit because he'd have to come up with what a definition that people would accept of what it means to think. He had a definition of what a machine was. He had his Turing machine, which defined that. But he talks about what would it mean if a machine could think or not. And of course, the title of the first section there, The Imitation Game, is probably familiar to you from the film of the same name, which looked at Turing's work mainly at Bletchley Park, played by Benedict Cumberbatch, of course. Really good film, covers a lot of interesting ideas and events. A few technical questions in it, but still a very good film, and I'm pretty sure it's available on iPlayer or wherever. And something that Turing thought about was AI in chess. So chess is something that only people could do, and some people would have thought only clever people could play chess. And that's been a bit of a marker throughout the development of artificial intelligence, as we shall see. So Turing wrote the first chess playing program. Now I say program because he didn't have the hardware to run this on at the time, so he never actually implemented it. But in principle, he had a set of instructions that would have played chess. So we move on to the 1960s. Some of the waypoints along the way. Eliza was the first chatbot. So you're probably familiar with chatbots. If you're looking for online help these days, you might get into a chat with a bot, a program, not a person. And the first one of these, way back, Weizenbaum developed that in the 60s. Another interesting program around then was called MacHack, and that was a chess playing program. And it was rated as being about a class C, which equates to the average club player. So now we actually had a chess playing program of reasonable capability. So in the AIs, in the 1960s, AI was promising much. Was it promising too much? Was there some hype? Leading to the 1970s. So one of the developments I want to mention is in the 70s was a program called MySyn, which performed medical diagnosis. But otherwise, the 70s were a bit of a low. And this is the first instance of something that people suggested was the AI winter. That is to say that they were that AI was not producing the sorts of outputs that people had kind of expected, perhaps had been over promised in the 60s and hadn't really come about, and a bit of a down. So we move on to the 1980s. Now, it must have been sometime in the 80s that I read a paper. I'm sorry I didn't keep a copy of it, but I'm pretty sure I read a paper in which some expert said computers are all very well, but computer chess playing programs are okay, but they'll never beat a grandmaster. But the 1980s was an interesting time too, because there was something called the fifth generation project that the Japanese government announced. And this was going to produce various things, but in particular, they suggested that they were going to build computers that had artificial intelligence built in to the hardware. Now, at the time, Japan was very successful economically, and this provoked something of a reaction in other countries. In particular, in the UK, we had something called the ALVI program. So Alvey was the head of BT, who was commissioned by the government to write a report on the fifth generation. And his report concluded that there should be some reaction to this, and this resulted in a lot of money being made available for AI research through what was known as the ALVI program. So, in a sense, this was certainly a high in terms of AI research because there was a lot of money going towards it. Now, I've done a bit of searching and I cannot find a single example of a product which came out of an ALVI project. Now, that's not to say that all that money was wasted, because no doubt there were techniques and ideas that were developed within those projects, but nothing that led to a direct product. And the fifth generation never really came to very much. So we go on to the 1990s, and of course, a important event in there was 1996, where the computer program Deep Blue defeated the world chess champion Garry Kasparov. So suddenly we've gone from computers will never beat a grandmaster to computer beating the world champion. Onto the 2000s, and we get to things like ChatGPT. So let's have a look at that in a bit more detail. What is ChatGPT? It's what's known as a large language model, or LLM. And what does that mean? How does it work? Well, let's look at predictive text. So on your phone, you will have predictive text. And suppose I want to type on my phone the sentence, "The boy hits the ball." So there's my keyboard, and straight away, the software has anticipated that the word I might want to start with is "the." So it's anticipated I, the, or I'm. So I can select "the." And it suggests the next word might be first, only, or most. Well, that's not what I wanted. So I start typing, and I have to type two letters of B-O of boy, and then it anticipates that it's likely to be boy. Straight away, it suggests that the next word might be hit or hits. So I select hits. Again, straight away, it anticipates that the next word will be the. So I can just select that. And then it anticipates again straight away ground, ball, or wall. I can select ball. So there I get my sentence. So how did that work? Well, the software has statistics on how words are used, and that's to say how I use words, how I have used words in perhaps previous sentences that I've typed, but also how other people use words. Millions of examples of the words orders. And an LLM is much the same, based on millions of examples of text from the internet. So ChatGPT scrapes pretty much all the text on the internet. It sees words, how frequently they occur near other words, and puts them together. Which leads us to the point where we need to discuss something called the Chinese room. This is another thought experiment, and this was devised by this chap, John Searle, who is a philosopher, in 1980. And he said, imagine you have a room. It's a sealed room, but there are two slots in the walls. And inside that room, you put John Searle and a big book. Now, through the slot in the wall, somebody feeds in some text in Chinese. Now, Searle does not understand Chinese. However, he's got this big, clever book, and he can see the symbols on the paper that has been fed in, and he looks up in the book, and the book tells him that if you get this set of symbols in, you generate a different set of symbols to go out. Now, what he doesn't know is that the symbols coming in represent questions, and the symbols going out represent the answers to those questions. Remember, Searle understands nothing. He does not know Chinese. All he can do is match the symbols. But to an external observer, it appears as if the room understands Chinese. And remember, what Searle is doing is quite similar to what we saw in the 1950s writing programs. You look things up in a table and you just copy them down. So you look up the load instruction, you write it down. This looking things up in a table like looking things up in the book. But in practice, it looks as if the room understands Chinese, but it doesn't. And ChatGPT is like the Chinese room. It takes inputs and generates outputs. But it doesn't have the book inside, it has the whole of the internet. But it understands nothing, no more than John Searle understands Chinese. Or to look at another example, a really handy program is Google Translate. Here we are translating between Chinese and Russian. Google Translate understands nothing. It works like ChatGPT. It's got examples of text on the internet. It looks at frequencies of words which occur together and is able to generate the translations. And it can do this by comparing writing in different languages. And for this, Wikipedia is very useful. In Wikipedia, you can have a page about, in this case, the Chinese room in English, and you can have a corresponding page in another language, in this case, French. And by looking at the frequency of word occurrences and those two pages, it starts to be able to translate between those languages. Of course, it's not just that page. There are millions of pages in the two languages that it will use. But it understands nothing. Does it matter that it doesn't understand anything? You get inputs and you get the outputs that you require. Is that sufficient? Statistical AIs are good, as we see. As I say, they generate the outputs that you might want, but they cannot explain their reasoning. Does that matter? Well, there are other AI technologies which can give explanations. And where might that be important? Well, let's think about medical AI. I already mentioned in the relatively early days that Mycin was a medical AI program. We can be certain that AIs are going to become increasingly important in medicine. We have a shortage of doctors, and one way of helping to deal with that was to make increased use of AIs. So suppose you have an AI which diagnoses some condition A and suggests a corresponding treatment. But what if there's some similar condition, a condition with a similar symptoms, this condition B? What if there is a similar condition with similar symptoms, B, with a completely different treatment? Wouldn't you want to know why the AI had said it was A and not B? And an example would be chest pain. So chest pain can be a symptom of a heart problem, a possibly fatal heart problem. But if your AI says no, it's not a heart problem, it's this other thing, you don't need any treatment, or take some paracetamol or whatever, wouldn't you like to know why it had decided that and not the more serious heart condition? And then, of course, that raises the question, if you have a medical AI which can explain its reasoning, does that mean that it understands medicine? I'll leave that as an open question. So a summary. Remember, I say that AI is getting a machine to do something previously only done by people, that moving target. And we've had a quick run through some historical examples of this kind of AI. My conclusion is that in addressing the title of this talk, ChatGPT understands nothing. Leaving open the question, will we ever be able to say that computers do understand things? And does it matter whether they do or not? There's one more question I want to raise, and you might say that this is the elephant in the room. Perhaps it's the elephant in the Chinese room. I've skirted around and haven't addressed what does it mean to understand something. I guess we all have a instinctive feeling that we know what that means, but I haven't addressed that. Now, at this point, if I was giving a live talk, I would invite questions from the audience, but obviously that's not possible on a video. Nevertheless, I would be happy to address any questions that you may have, and you can send them by email. I'm alistair.edwards@york.ac.uk or at ADN-Edwards on Twitter, X, whatever you want to call it. So as the saying goes, if you have been, thank you for listening, and I'll be happy to receive any questions or feedback. Thank you.